welcome everyone to the first ever Ewasm decision hangout, which should be a prototype to prototyping the decision process on changing anything in Ewasm. And for every one of these calls, we record them. We will try to live stream them, but at least publish the recording. Anybody is free to join. Each of them is usually announced 2 weeks prior, and we have a GitHub issue to track all of these details, as well as all the proposed agenda items, which everyone should propose agenda items prior to the meeting, preferably a few days before the meeting, so everybody is ready to read on them. For this meeting, we already have, it seems like, 7 agenda points to discuss. And I think we haven't done the groundwork to make a decision on what kind of order we want to go through these agenda items. Anybody has anything to add to this or any questions so far?
Alexis here. I'm glad to be on this call, and I've looked at the agenda, and I probably won't be able to contribute much to any point apart from the precompiles, and I won't be able to stay for the whole call. I will probably need to drop off in about half an hour. So if you could get that point, like the precompiles point earlier, that would be great.
All right, so the agenda points we have is one of them is the precompiles discussion. And we have one other tinier issue, which is just proposing to change one of the exposed function names, which should be a very simple decision to be made. There's one bigger one to discuss, how certain exported functions can stop execution. 3 of these would be a self-destruct, a revert, or returning data and finishing execution. That probably is a bigger discussion. And the last one of these extra changes is a versioning discussion, which probably we should just skip for this call. I have 3 giant topics, I would say, proposed by Pavel. One of them is how agree to or maybe discuss a process of how we define the interfaces and how can we change the interfaces. And I guess as part of this is a proposal to maybe offload some of the discussions to each research as opposed to GitHub. And the last proposal is again probably a really big topic, discussing different metering options. So I guess based on that and based on Alex's request, does everybody agree to start with a discussion on the precompiles?
Yep.
All right, I can give it a bit of intro to the precompile discussion. So basically, this idea came based on a couple of face-to-face discussions at the Ethereum Client Developers Conference, of which I think all the recorded talks and videos should go up soon. I'm actually looking forward to it. And there was quite a big block about introducing Ewasm. And basically what this precompile proposal means is, so far there was an understanding. So initially the understanding was that Ewasm would be introduced in the main chain parallel to EVM. And at some point later, this idea shifted to having Ewasm introduced through sharding. But it seems like the sharding still will take quite a bit more time to be more finalized and be in the stage of discussing Ewasm or execution engines. However, there's quite a big need and push from the community to have more features in the main chain. And most of these features come in the form of a precompile because the EVM wouldn't be like flexible or speedy enough to introduce certain features. Some of these features, for example, would be new hashing algorithms or new algorithms regarding crypto mostly. So the idea here is to maybe introduce a subset of Ewasm, which this subset would be enough to implement precompiles. And during this process, we would gain a couple of things. with a reduced exposure to some of the risks already identified to Ewasm. So basically, if we decide that these precompiles follow the way precompiles were designed so far, that means they have some kind of a gas calculation logic in them. To Ewasm at all. So basically, this reduces the entire process onto introducing a Wasm VM into the clients, writing these precompiles once in a language which can be compiled to Ewasm, testing them fully, and that should be it. This removes one of the other concerns which comes up quite frequently, is the problem of JIT bumps. This should be eliminated because, well, fairly eliminated because we don't need to prepare for any kind of contracts. We have this limited set of contracts. Yeah, I guess this is a very long intro to it. So if anybody wants to speak up and raise any concerns, or yeah, please comment on this proposal.
If we're talking about user deployed precompilers on the main chain, another concern that we might have is a implementation specific vulnerability with the JIT engine. For example, if we have every single person on the chain executing a user deployed precompile that exploits a vulnerability in the JIT that allows it to execute arbitrary code on every single host, basically every node on the main chain could be compromised because of that if they're using well, every node that's using the same JIT implementation with that vulnerability. That's one of the concerns I have.
I think probably this explanation wasn't clear enough. I can clearly see that. This is kind of like a limited proposal, so it wouldn't enable and open up the door for anyone to deploy contracts. It is really to introduce precompiles as they are today in a much more quicker fashion. Because right now, if we need to introduce a precompile, we need to first agree what's the API, how the precompile works. Then all the clients have to implement their own version of this precompile with native libraries. So the Go client would do it in Go, the C client would do it in C, etc. And tests have to be created for all of these, and then somehow it needs to be ensured that no consensus bugs are there. So this is quite a lengthy process. We could save here quite a bit of time if there's only, and probably introduce other kind of risks, if we have a single kind of implementation. And we wouldn't need all of the clients to implement it natively.
Yeah, so I completely agree with this. If we introduce it as like a first step, and we don't gonna open it up completely for at least in the beginning, I think it's very useful to just introduce it as the first step, where it's still the core developers will be adding the precompiles, but it's simply going to happen much faster, and they will be less reluctant into adding the new precompiles.
Yeah, for me this sounds good, even better than good. So I think that are we going to actually use metering contract to estimate the gas cost for precompiles, or that would be something for later? And for now, we just provide arbitrary formula for calculating the gas cost.
Right, just to reiterate, that's one of the challenges with this approach, is that if people are running an Ewasm reference implementation of a precompiled, then there's no problem doing the gas math. But on the other hand, if the one particular client decides to implement the same precompile natively, then we're going to have trouble getting the gas metering to line up.
I think the gas metering probably opens a lot of different questions, because, so for example, we have to come to, I guess, an agreement on the gas metering, and that may delay the process. But on the other hand, coming up with random gas calculation rules as we have today is a challenge on its own. So I don't really, at least for myself, I don't really have a preference for either of them. But probably we need to explore both of these options a bit more depth than we have done so far.
Well, I think if we're using the Ewasm kind of precompile system as a way to simplify deployment of precompiles on the main chain, then we shouldn't be thinking about, well, each client implementing its own native version of precompile, because that wouldn't really be much of a difference from the way things are now. What I'm saying is that the precompile implementation should be, well, I guess what you're saying with the Ewasm reference implementation makes sense, but at the same time, it could also be beneficial to steer away from native implementation of precompiles that are, well, initially implemented in Wasm, because we could figure out the gas calculation, and it would generally be kind of agnostic to each client, in the sense that the only thing the client would have to implement if they want to is their JIT.
Well, yeah, I think it's if we do the precompile in the first step just with the introduction of the new kind of primitives, then it makes some sense to somehow inject it in the code, because then you have to have run exactly the same code as everywhere. But then the question is, how do you do that? Do you do it via function calls, or you just have like a counter inside your code, which is incrementing through and does something when it reaches a certain point, which is going to be more efficient?
I would put this one comment on the table. So following up from Jake's thoughts, if we allow clients to still choose their own native implementation of the precompile, as well as we allow clients to use the Ewasm version, then we lose one thing. We cannot choose metering. We have to come up with these random gas calculation rules. But second, we gain something, which is we don't require all the clients to support Ewasm. We can have, at least initially, we can have a subset of clients which do Ewasm, and the rest may decide to do it natively. And then it's a much more slower process to expand that support base. But on the other hand, we may be able to push this through much quicker. I'm not sure which makes more sense.
I mean, as far as understanding,
in the case of,
sorry, go ahead.
Okay, so, in the case of, sorry, just go ahead, dude.
Yeah, I just, I mean, I don't know much about the Ewasm, but I read a little bit about it, and apparently you can construct basically the static graph of the program flow in Ewasm. So it allows you to essentially post-process any candidate implementation and just inject something in there. I thought it would be quite simple, and then it doesn't really matter whether the client implements the Ewasm natively or not. The actual code will be there, but yeah, I mean, and then if they want to be compatible with the like in a consensus compatible, so if the client wants to do the natively without Ewasm and they want to be consensus compatible, then they will have to do it in other way. Otherwise, they will just fork from the Ewasm supported client. So I don't think it's a big problem.
That's similar to what I was going to say. Basically, in the case of just trying out the Ewasm precompile system, it does make sense to not require all clients to support the Ewasm precompile system. But at the same time, that introduces much more surface for consensus failure, because you have some clients running their native version and some running the Ewasm implementation, and that requires a much more kind of like wide surface for reviewing each precompile. Basically, that's the drawback of not requiring all clients to use the Ewasm precompiles, because then you'll have to vet both the Ewasm implementation of the precompile and the native implementation.
This is Paul here. There's no way really to force people to not have a native implementation. They're going to do whatever they want if they have a speed up. I think we should. First, Axic, are we talking about issue number 104 for Ewasm design?
Correct.
Yeah, I think we have to also, I think it would be wise if we can just automate computing an upper bound on gas use. To do this, we would also have to restrict what we can do in Ewasm. For example, we wouldn't allow while loops. We would have to, be able to know how long each loop is going to run, but, statically before it runs. So we would have, like, finite, predetermined loop number of loops. We'd also restrict these call indirects, and then we would prevent recursive calls. If we can do these three things, I think we can compute statically, as Alexei was speaking, based on the abstract syntax. Maybe we're going to be able to compute, I don't know for sure, but we can maybe compute an upper bound on gas use. Once we have this upper bound, that would be our automated computation of gas metering. Perhaps we would, sometimes have some error cases, but we would, use that upper bound no matter what happens. And I think we should precisely do this, automate this gas computation by doing some static analysis.
I wouldn't go as far as restricting the loop count. I agree with restricting the recursive functions in indirect, I think, but restricting the loops, it's probably a bit too harsh. And I wasn't thinking about actually pre-calculating the upper bound, but simply post-processing the Ewasm binary, just to basically inject a counter in every loop, and essentially that will just increment it in a loop.
Yep, that'll work. There will be a little bit of a slowdown because you have to compute the metering. But yeah, that works, I guess.
Yeah, but you basically can do it in a way that doesn't require you to have some sort of trust checks, because as you just post-process it in such a way that you introduce a new variable and then just increment it instead of calling some sort of consume gas function. And in the end of the execution, you just basically pass this variable back.
Yeah, there are many options to compute gas and to meter things. One is to have an internal variable, maybe a global variable in WebAssembly. Another is to call out to use gas. I don't know if there are security concerns for one or the other. But yeah, there is overhead, certainly. Personally, I would like to see full static analysis. We only allow 4 loops. We follow the Viper model, where we only allow 4 loops of a certain number of iterations that are known beforehand. This type of thing. But if we want to be very generic with our precompile, sure, we can allow while loops and arbitrary. We'll let the gas run as long as use as much gas as it wants to use.
So I actually would ask a question here. What would be the process? What would the best way to propose this? And I guess on what forums? I would think probably all core devs would be one of those forums to propose this idea. I also think it would need a bit more description, substance around it than the current issue has. But I'm also wondering if we should kind of spend a tiny bit more effort on looking at what kind of precompiles people want, maybe even implement one of them, and just have some kind of more information around this idea than we have right now. And we could probably prototype that with CPP Ethereum, because that should be working. And what kind of like times or like milestones we are shooting for. Yeah, just in general, probably discussing the process of proposing this to the wider audience.
Well, I think we can, as an example, precompiles, we could take something which is going to be like things like a BLS signature verification, which will be useful anyway for the future process, or something that Nick Johnson has asked about, which is some of the curves for the DNS verification or something like this. So yeah, you could get a couple of examples like this, which have some practical use and just implement them.
Yeah, I would choose something that is waiting for a long time already. So one I remember is Blake Hash, and the second one is what Alexei mentioned, this elliptic curve for some other kind of, that's also used for DNS. I mean, there was some team that wanted that really much, and they implemented, I think, that in every client. So that would be like my two candidates for that. But maybe there's more in EAPs that I'm not aware of.
Yeah, I guess we need to have like a really good understanding of how far clients are regarding Ewasm support, and we get some kind of update about that last week. Probably like one of the blocking parts, or like one of the core parts we have to probably wait for, is supporting Go Ethereum. But I think that's like really in a good state. And then probably writing one of these precompiles, as were mentioned, and potentially testing them and looking into different kind of metering options at or around the time we propose this, probably would be like a good way to take it. But probably this metering, whether we would want to have like random gas rules or we would like to use a more deterministic process, probably that is one of the bigger questions to be answered.
I will, this deterministic process of, pre-computing gas, an upper bound on gas before it runs, we need an algorithm. I don't, my sort of hope that we would use this would need to be supported by some evidence, an algorithm, a runtime of this algorithm. And I have done nothing like this. I haven't provided anything. So I think it's one of my jobs to sort of write down an algorithm, implement it in PyWebAssembly, show that I'm computing an upper bound of gas, maybe proof something that I'm doing what it's supposed to be doing. So I guess that's one thing that I owe you guys if we're going to do it with the pre-computing an upper bound way.
So is the upper bound which would be charged to the user?
Yes, no matter the run, even if it sort of errors out early for like an invalid input, it would always be charged the upper bound. Yes.
Do you think that would be like a good incentive for all kind of precompiles, or certain types would be good to be done this way?
Certain types, yeah, certainly. If you need a while loop, for example, this would be bad, because if you don't know how long it's going to run before you run it, certainly you would have to give a gas limit. So certainly you have some idea of how long it's going to run. But maybe there might be some algorithms where you're doing some search, and sometimes it might find something right away, whereas other time, and you would like exit early with just use a little bit of gas. Other times it might run much longer. Yeah, so you lose some flexibility with this deterministic way, because you'd have to have an upper bound. I argue that you will have an upper bound one way or another, because you have to have a gas limit anyway. And if you need a higher gas limit or some algorithm with more, that has more iterations, then you can make a new precompile for, you can, do whatever. But yes, certainly this limits the algorithms you can use to be not Turing complete, but almost Turing complete. But there's a Brandon Ike Twitter thread about maybe almost Turing completeness is enough. Obviously, this is bad for marketing, because EOS or someone might say, yeah, well, we do have Turing complete. But I think it's worth at least leaving this as an option among the other options.
Yeah, so if we look at some of the hash functions, I think pretty much all of them have a fixed number of rounds, and in each round you have a fixed number of operations. I think that might work well in that case. So maybe there are like the whole class of precompiles that would for which that would be enough. But I'm thinking if we decide to do that, we would be able to extend it later on if we realize that actually that wasn't enough for other cases. I think we should explore whether we can put this limit now and then remove it later on if it's really needed.
I think it's not enough even for hash functions, because it works like it has a constant cost for a single block, but most of the implement precompiles we have can hash arbitrary length of data, so it's linear. It's proportional to the input length. So I think that breaks this model already.
I just want to mention is to be conscious about time, because this was scheduled to last 20 minutes more from now, and probably we're not going to answer all of these questions we have. But probably it would be good to some kind of lay out a plan how we're going to work on this, communicate about this, and have maybe more calls. I think everyone on this call is part of the Gitter channel, so probably that would be a good way to quickly discuss matters. But probably we need to figure out who is interested in writing some of these actual proposed precompiles in a language compiling to Ewasm, and who would be interested in figuring out appropriate gas costs for it, whether through some kind of deterministic process or whether through other means.
Okay, let's move the discussion to the Gitter, because yeah, I think we spent a lot of time on this. Yeah.
I guess anybody who is, I mean, anybody from us on the call, or even anybody on listening to this from recording, please also check out there should be a link, I guess, on YouTube, but please check out this Gitter issue and maybe leave a comment, and also join the Gitter channel.
I suppose this also ties into another decision we should make, is whether to move some of the discussion over to ETH research. I don't have any particular opinion on it, but I suppose that that idea there also ties into another decision we were supposed to make on this call.
Yeah, I wonder how much of this would qualify under the research category, and whether ETH research is the best point to have discussion about this, or is this a more practical discussion, which is usually part of the all core devs process? Or the third option, as of today, to have it on this Ewasm repository. What are the proposals to what kind of parts should be moved to ETH research?
I think that certain topics, such as more like high-level design discussion, could be moved to ETH research. For example, the EI design in things that are non-trivial. For example, an example of something trivial would be the name of a method, and an example of something non-trivial that could be moved to ETH research is probably more like how the EI should be designed and what it should support in a way.
Pavel, you were the one adding these three proposals to the agenda.
Yeah.
Do you want to create appropriate issues for them on GitHub for the moment?
Okay.
And yeah, I mean, personally, I would be happy to move certain things to the ETH Research Forum if that brings us a lot more response and discussion, because probably that is the thing we're lacking at the moment.
Yes, that was one of the reasons. It's to like expose the issues we are heading. But I only meant the EI for that, because it somehow also affects account abstraction and maybe something like that. And I don't have full picture of these ideas, and yeah, I don't think there's anything else at the moment. that is worth to move it there.
Yeah, with account abstraction considered, it seems like a good idea to move the topic of the EEI to ETH research, just because it's also kind of bottled up in the design repo at the moment.
Comment. I think we should maybe enumerate lists of options, sort of spend some time writing things down in a way that's easy for people to understand. If we start posting things on ETH research that is sort of not sort of organized, then it might look bad, and it might the discussions might not be what we should discuss. So I think we should spend some time curating and writing things nicely, enumerating all of our options, and then letting people sort of see the high level of everything.
Paul, would it make sense for each of these discussions to have an entry on our GitHub design repo and then maybe iterate there before it goes to the ETH research, or at least for any ETH research topic, there would be some kind of cross-link from there, so it still could be tracked through our design repo?
Yes, and even more so, we can maybe try to build some prototypes whenever possible, accumulate statistics, whatever the case, anything to sort of, so we can, give people that are going to make, the rest of the community some sort of information and some sort of clues and hints on what's better and that kind of thing. Yeah, so let's iterate first.
Okay, Pavel, do you want to, since you posted those, do you want to create an issue for each? And you just listed the EEI redesign process as one of the points. Do you have, can you give an overview about that with any kind of proposals already, or it's just like a high-level topic?
I can say 2 sentences about that. So my idea is to actually review current EEI methods one by one, and some of them are kind of obvious, and probably there's not a lot of discuss about, and some are not like that. But like what I wanted to do is to actually create separated threads about each one of them, and maybe list some alternatives and some, to mostly have some on in-text discussion about each. And when we finish that, I would propose the whole document as another version of the draft, and that could go to bigger peer review. So depending if there's actually something that it's not very clear, we can reach for ETH research in some cases, but mostly I will keep it as a GitHub issues. Actually, I created, I think, 2 pull requests, which like each of them tries to address some basic EI methods, improve documentation a bit, and that I would see it to proceed with that. That's all. I can describe this as well as a meta issue describing the process idea.
Please do. I think it would be really important to have an issue about this and have more clarity. And probably that would also give us like a framework how to make decisions.
Yeah, I cannot promise the decision framework, but I will do my best to have good description of that.
Do you also want to give like an overview of the alternative gas counting implementation as a proposal, or it's just
it's probably better to skip it for this time.
All right. So I wonder if we should. So one of these easier EI change proposals, we're falling into the category of a simple name change, which I gather is kind of like the sentiment that may be okay with the further discussion on int research. But like one of the other points here is this anything regarding self-destruct. That probably is something we cannot make a decision on this single call. Is anybody interested to try to make a decision on something as part of the first call?
The easiest one is the return to finish, and it doesn't matter to me. Do whatever. I used return underscore whenever I needed to not conflict with Python return, and I think a lot of people would do like return underscore or whatever. This in WebAssembly. Hello, can you hear me?
I think you were breaking up. If you could just repeat, please.
Yes. For the return to finish. If it doesn't matter to me, I use return underscore. I think in WebAssembly, the return, there's no keyword. You're just using UTF-8 strings for the imports. So I think it's fine to use return for in terms of WebAssembly, but there might be some conflicts in
Paul, are you still there? I think we lost Paul.
Yeah, for me this change is it's improvement, so I would go with that. If there's the ideas for different name than finish, that can be proposed separately. But yeah, but it's improvement of what we have at the moment. So I agree to merge this one.
Yes, I agree with that. I think we need to change this name because we have some conflict in many languages that uses this as a keyword. The only thing I see is that, for example, right now for each one of the EI methods we see that each one of these methods is related to an opcode, and if you already know the opcode, you can guess what the method is doing. So maybe for the when we change it to from return to finish, that idea is not very clear when we are talking about something like the return opcode. So maybe we could change it to something like return data or something like that, so we can still know that it is related to something like the return opcode.
Yeah, I see that there's a potential issue. Return data probably is a relevant name, but unfortunately, I think it would be. I'm not sure if it would be confused with return data copy / return data size, but probably this is something we should actually discuss. So Hugo, if you want to leave a comment on the issue that could help in sparking the discussion.
Sure.
And I also think, again, looking at it, that I think it depends on issue number 72, which is the self-destruct clarification, self-destruct / reverse / return, which was another agenda point. Because if we call it finish and actually the execution isn't finishing because it's still up to the contract to finish the execution, then probably finish is misleading.
Right.
So yeah, I would say we cannot really make a final decision on this, but please leave comments on whatever was said, because I think it was useful input. And I hope we can make a decision on it on probably on the next call. But before the next call, we should we should think a bit more about the process of how we make decisions and how whether we move any of those into each research. So what do you think? What would be the best way to discuss this? And what time should we have a second similar like core devs, Ewasm core devs call or Ewasm decision hangout? Should we have one sooner, or should we have one in 2 weeks, or even 3 weeks, and have more of this other discussion, but the process done, or should we have this call to discuss the actual process, brainstorm the process rather?
I like the model that the Ethereum Foundation uses for EIPs, where you submit a proposal, you do some background on it, you have some like good pros, cons, and things like this, and then people will respond, and then you'll have a text discussion where people have time to think about things, and then I don't know, but I like the model of EIPs.
Yeah, I like it too. I mean, I would say like it can be some like introduction given on some of these meetings, but then it should go to some offline form in text or something like that to actually accumulate pros and cons on paper. And if it's kind of like reach any stable point, then we can come to the meeting again and discuss like maybe some, yeah, and then make like some final decisions on that. But this middle term process, which is quite long, it doesn't suit online meetings very well.
Well, the idea of an EIP process is that the discussion happens asynchronously offline, and then, you know, once a proposal is deemed to be technically sound and has been merged and stuff, then, you know, someone can bring it up on a meeting and champion it. And at least in theory, the vote to sort of approve it should be quite straightforward at that point. I think that model is pretty efficient.
So can we create these proposals as an issue on the design repo for the moment?
Yes, but it's important to say this, that sometimes you have some sort of proposal. When I had students, I would tell them, write it down, like clearly write it down exactly, every word is important. And sometimes when you do that, the issue sort of disappears because in the act of writing it down, or in the act of writing it down, you have new ideas. So I think that we should have it in the design repo, but I think if you're proposing an idea or you have some sort of something to write, just write it down clearly. If there's something unclear, say, I'm not sure about this part, but you know, it should be written down, not some vague thing that is sort of interpreted differently by everybody. Then we don't know what we're talking about. So that's it.
Yeah, I think we are coming to an end to the allocated time slot. And I personally need to leave roughly at the end of it. But if there are any last minute comments, proposals, please say it right now.
Alex, when do you think you'd like to schedule the next of these calls, or maybe how often should they be scheduled?
I was shooting for every 2 weeks, strictly every 2 weeks. I think we can try to do that, but in a few days in a week, we should know that it makes sense to make it or not. I wrote up some of these comments we have made this call as a comment onto the decision Hangout issue. But basically, most of the comments I made were like we need to create issues for all of these, and we need to discuss them there. And if they are kind of ready, we have to bring them onto the call. So I hope we can make a call in 2 weeks if everybody is laying out these ideas more clearly in a written form. Actually, Lane, did you keep minutes?
No, I haven't, but we have a recording on YouTube, so we can still do that.
Do we want to publish minutes or just publish the recording and have this summary there? I think we're fine not having the minutes for right now.
Yeah, I think at the point where we're actually making decisions on these calls, having the minutes is pretty important, so I'm happy to do that.
Well, thank you everyone for being here today, and sorry that I want this like a really strict schedule for the moment. I think we made some good progress and probably realized some of the limitations we had so far. So I'm really optimistic that this is gonna be like super cool, and we're gonna make all of these changes really fast.
Thanks, Alex. Thanks for organizing.
Yeah, thanks.
Thanks, Alex.
Thank you.
Thank you.
Bye bye, everyone.
Bye-bye.